All right. Now, let's talk about what we mean by statistics. And the answer depends on how you ask the question. Because if you come to me and say, well, what are statistics? Like the field of statistics. I'm going to take a statistics class. What can I expect? What does the field do? I mean, what is that? That's a little bit different than asking the question, what is a statistic? So the first thing I'm going to do is I'm going to explain to you what we mean by the field of statistics as a discipline. What is the discipline? What is our goal? What are our goals? Okay. And then after we cover that, then we'll look at what is a statistic. Okay. So there, a general definition for statistics I like to use, and that is to say that statistics as a field is an applied branch of mathematics that describes, summarizes, and draws inferences about data. All right, so let's take that apart a little bit. An applied branch of mathematics means that you're doing math, but for a reason. All right, I know that sometimes students feel that they take a math class and they have no idea what they just did to the numbers and why they did what they did. All right, it's very esoteric. Why were we calculating the derivative of, et cetera, et cetera? All right. Statistics is different because statistics is done for a very good reason. You are analyzing numbers, right? Because it talks about data here, and in statistics, the data takes the shape of numbers. So you are analyzing numbers. You're using math on those numbers for the purpose of either describing what those numbers are telling you, summarizing what the numbers are telling you, or even drawing inferences, what those numbers actually mean. Now, we're going to talk more about the purposes here, describing, summarizing, drawing inferences. We're going to talk about that next, okay? But for now, I just want you to know that statistics as a discipline is using numbers. That means analyzing those numbers to tell us something. We're either describing something, summarizing something, or using the numbers to infer something, to tell us about something else. Okay, so that's where we're going to go next. There are two different categories of statistics that allow us to describe, summarize, and draw inferences. All right, so you can think of this as statistics uses tools, right? Statistics are tools, in fact. They're tools that we use to describe, summarize, or draw inferences. Now, think about a traditional toolbox, right? One that you're going to find in your garage. That toolbox may have two different types of tools in it. You have the handheld tools. So those are, the hammer, the saw, the screwdriver. But also in your toolbox, you might have power tools, like a power drill, for example. And those different types of tools are used for different purposes. So for example, if I want to open up my watch face, okay, I have a wrist watch on. Hopefully you know what that is. It's not a Fitbit. It's one of those old watches, with hands that move, etc. All right. So if I have one of those old-fashioned wrist watches on and I want to replace the battery, I'm going to need to undo the screws at the back of the watch, right? Okay, so which tool am I going to choose to unscrew the screws? Am I going to use a teeny tiny handheld screwdriver, or am I going to use my cordless electrical drill? Hopefully you selected the first one. All right, tools are, even though we kind of think of the handheld tools as inferior to the power tools, that's not necessarily the case, right? The handheld tools are best and most appropriate for certain jobs, and the power tools are best and most appropriate for other jobs. So that's kind of the same thing when we talk about, or the analogy I should say applies when we talk about descriptive statistics and inferential statistics. Descriptive statistics are like the handheld tools. Inferential statistics are like the power tools. Now, I don't want you to think that descriptive statistics are inferior to inferential. Descriptive statistics are the tools that we need when we want to describe or summarize data, right? These are the appropriate statistics. If all we want to do is get a little snapshot, let's see if this works. Aha, get it? Polaroid snapshot? If all we do is want to get a little snapshot of the numbers, what do those numbers look like in general? Are they high on average, low on average? Are they all around the same number, or the number is all helter-skelter all over the place? If that's what we want to do, then descriptive statistics is the category of tools that we should be using. All right, and they're mentioned up here, right? An applied branch of mathematics that describes or summarizes. Those were the first two purposes of statistics that we talked about. So let me give you an example. Let's say that you want to go and explore the Grand Canyon. All right. And you want to somehow capture all the grandeur that describes the Grand Canyon. Well, you cannot talk about and take pictures of every rock, every tree, every animal in the Grand Canyon, because that's just too much information to absorb. But what you can do is you can take a representative picture, right? You can get your camera out, take a nice picture of the Grand Canyon, and it will capture the essence of the Grand Canyon. It won't give you everything, but it'll capture the essence. And that's kind of what descriptive, if you say descriptive statistics often enough, it's easy to fumble over those words. So, forgive me. Sometimes I'm having to repeat those words just because I screw them up. But anyways, okay. Descriptive statistics is like taking a picture of a large set of data set. You're taking that picture in an effort to summarize it. You want to describe it, but you're going to have to condense the information into one or a few numbers, because statistics, let's face it, your statistics isn't a picture, a literal physical picture, but it operates much the same way. All right, you use descriptive statistics to summarize a large data set. So you might calculate the average of that data set. Now that's something that you're probably already familiar with, right? You know about averages. And in fact, the average that you are probably already familiar with is the mean. The mean is a statistic, and we calculate it just by adding up all the numbers in our data set and dividing by however many numbers we have. So if you wanted to, for example, calculate your average or mean test score, there will be 5 tests in this class. If you wanted to know, well, what is the average or mean of all 5, then you would simply add up the 5 test scores and divide by 5. All right, so that's a mean. That is also a descriptive statistic. It is describing or summarizing your performance. Now, you probably don't really need an average to understand 5 numbers, because that's kind of easily processed by your brain. But what if you took 50,000 tests? Well, we won't even go there, right? But let's just say you did, hypothetically, take 50,000 tests. How are you going to get a good idea of how well you did or didn't do? Those are too many numbers to process, right? So what you can do instead is you can calculate a descriptive statistic. Calculate the mean. See how high or low you performed based on this one number. It will give you a little snapshot of your performance. All right? It'll help summarize those 50,000 numbers. Another thing that you can do besides describing by using, an average is you can look at all 50,000 numbers and then calculate a statistic that will tell you whether or not your numbers are highly variable, so they're all over the place, or they're not variable. They're kind of clustered, grouped together around a specific value. So if test scores can go anywhere from 0 to 100, and you got a very low number for variability, that's telling you that all your test scores were right around the same number. Okay, so these are examples of descriptive statistics that describe and summarize. They take a large group of numbers and they crunch them down to one or two numbers that help you to make sense out of your data set. They are the handheld tools. Let's talk about inferential statistics, which I've likened to the power tools. All right. Now, the reason why I liken them to the power tools is because they take your data set, all right, the data that you collected from a sample, maybe a sample of people, a sample of dogs, a sample of, I don't know, bacteria, whatever it is that you were studying. They take the numbers that you've collected from the sample and use those numbers to tell you something about the population that your sample came from. All right, in other words, you're using sample data to infer something about the population. Now, we're throwing out a couple of terms here, sample and population. All right, I am going to go into a bit more of an explanation. I know you might think I know everything there is to know about what samples are and I know what populations are, but just in case, we are going to go into a little bit more detail about each. All right, but for now, do you understand the difference between descriptive statistics and inferential? So descriptive statistics, these are just taking numbers. It doesn't matter where those numbers come from, right? It doesn't matter, well, you need at least two numbers, but it doesn't matter if the numbers represent a sample of data or a population. That doesn't matter. As long as you've got a group of numbers, you can calculate descriptive statistics on them. You can take a snapshot of the data, crunch it down to help you make sense out of those numbers. Inferential statistics, you're also calculating them on data, but it's data that must have come from a sample. Okay, it has to be sample data. You've sampled from the population, you've got numbers, and now you're using inferential statistics to say something about the population that the sample came from. You're inferring, right? And those are exciting statistics. Just like it's not very exciting to pick up a screwdriver, a manual screwdriver, and screw something in or out by hand. It's kind of a little bit more exciting when you get your cordless drill and do it, right? But again, descriptive statistics has its place, and so do inferential statistics, okay? If you tried to use an electric drill on your wristwatch, you would destroy your wristwatch, okay? All right, so another thing about inferential statistics that's important to know before we talk about sample and population a little bit more, it's important for you to begin understanding that inferential statistics estimate the probability that what you found in your sample is true only for that sample. Okay, so if that's the case, if it's true only for your sample, that means you're not going to find it in the population. If I were to walk around campus, for example, and I just, grab the first 20 people I run into, that's presumably pretty random, right? I'm just going to grab those people, the first 20 I bump into, and I might calculate their age, the average age of that sample. Well, I might want to know, is this age actually close to what it is for the entire campus, right? The population at SUU? Or is the age of my sample only true for my sample? If I calculate the age for my sample and it's 23 on the nose, let's say, all right, then that's a truth for the sample. It's true. It's 23. How do I know? Well, because I had 20 people and they reported their age. I'm assuming that nobody lied. So, and I didn't mess up my calculation. So it's true. It's true for that sample. Will it also be true for the population? Well, there's no way of knowing for sure unless I were to get every single person's age in the population. Okay, and I've defined the population as the SUU campus community. If I were to do that, then yes, that would be true for the population, right? Again, it's because I had everybody. I didn't make a mistake in my calculations, so it's true for the population. But if all I have is a sample, all I know is what's true for the sample. 23 is their age. What is the probability that what I found, 23, is only true for my sample, and it's not going to be true for the population? Well, we use inferential statistics to estimate that probability. All right, so again, inferential statistics will give you a probability estimate, and it will tell you the probability that what you found in your sample is only true for the sample, and it's not true for the population. All right. Now, it has to be worded this way. You might think you can change the wording around and it will come out the same. That's not true. It won't work. All right. You have to say it this way. Inferential statistics estimate the probability that what you found in your sample is only true for that sample. It will not be true for the population. And again, we only know the probability. All right. We cannot know, and I'm repeating this many times because it is important, we cannot know what is true in the population unless we test the entire population. So, and how often do we do that, right? In research, it's almost never.